This is a video about the importance of the defense having access to the full context of calibration checks. Calibration checks aren't meaningful unless the defense and an expert retained by the defense has full access to the data that is associated with the calibration checks. A calibration check of 100 or a calibration check of 000 is meaningless unless you know that the qualified technician has controlled the ambient conditions in the breath room. You probably don't know whether or not the qualified technician controlled the conditions in the breath room based on the limited disclosure that we now receive. We need full disclosure of all of the air blanks that are associated with the calibration checks related to our clients. Both the calibration checks that are standalone calibration checks at start of shift and the calibration checks that are part and parcel of the subject tests. But if we're going to have all of that context, and we're going to know something about whether or not those air blanks are meaningful, we need to know about other air blanks as well. We need to know about the air blanks and the results of the air blanks that took place essentially from the point in time when the instrument was powered up from its cold start. And the reason for this is that an infrared instrument like the Intoxilyzer 8000C or the Intoxilyzer 5000C is constantly resetting zero. And so ambient conditions, changing ambient conditions, knowledge about that is very, very important to the defense in understanding whether or not the ambient conditions have been compromised in the room. And so we need to know about the results of air blanks before our client's standalone cal checks, the results of air blanks after our client's standalone cal checks, but before the subject test sequences. And we need to know the results of air blanks that occurred following our client's subject tests. In this video, you're going to see 4 different segments. First video at 1934 shows an air blank, a cal check of 000 using dry gas 45 standard. Now, lots obviously happened before this particular segment, but this is one of those strange situations where the instrument is treating a cal check using dry standard of 45 as being 000 because 0 has been elevated. Then the next segment at 1935 that you're going to see contains an ambient fail and a purge fail. Adverse conditions are still present. Ambient adverse conditions are still present. Then at 1937, the third video segment you're going to see contains an air blank, a calibration check of 000 using dry gas 45 standard, and then a normal air blank. Within each of those standalone cal check sequences, both the one that's the first video segment and the one that is the third video segment, everything appears normal except that the cal checks are weird. But what's significant is that in between those 2 standalone cal checks was video segment number 2, in which there was an ambient fail and a purge fail. What's also significant is video segment number 4 of what was going on at 1938, specifically an ambient fail and an air blank. And that one is really interesting because when that test is taking place, when the instrument is conducting the air blanks, that instrument is not being exposed to any adverse conditions. You'll see that the source of the adverse conditions has been removed. And yet even so, the instrument at about 1938 generates an ambient fail followed by an air blank. It's an ambient fail that's caused not by an increase in the ambient alcohol that exceeds 10 milligrams per 100 mils, but it's being caused because the adverse conditions have been removed. In other words, an ambient fail can be triggered on an Intoxilyzer 8000 or 8000C by any significant change in the ambient conditions. It's not just an increase. So the information that you read in the training aid is not completely true. An ambient fail can be triggered by a significant change in the ambient conditions, even if it's an improvement in the ambient conditions. That can indicate an ambient fail. And so it's important for the defense in preparing an analysis of the reliability of the calibration checks using a wet bath simulator or a dry gas system of alcohol standard. It's extremely important for the defense to know the results of all of the air blanks that are before the calibration checks, the standalone calibration checks and subject test calibration checks, before them, between them, and after them. And so my suggestion is that the defense should seek disclosure from the moment that the instrument is powered on.